For our robot, we are using Robot Operating System ROS to do the navigation. We are using two packages. One package takes care of odometry parameters, sensor information, transform configurations, and basically publishes the velocity to the base so that it is able to move. The other package consists of local cost maps, global cost maps, as well as a planner, so that when the robot detects obstacles, it can make the cost maps accordingly, and the planner helps it to create a path to the given goal. We will be visualizing this entire process through Arvis, and we can also provide goals to the robot through Arvis. So I have a raw score running over here, and I'm going to launch our first package. And I am going to run teleop twist keyboard. Our first package also consists of a mapping procedure, a mapping algorithm. We are using gmapping slam, and that is the first step that we have to do so that we can move around the arena and help the robot create a map that it can later use. And I'm also going to run Arvis over here so that we can visualize the map making process. So as you can see over here, you can see the robot transform trees as well as what the robot is seeing right now. The robot only sees the front of it because we are applying a filter to our LiDAR data so that it is only able to look at the front. And basically, I am going to be moving it around, and you will be able to see the map being formed as I go. So I'm using teleop twist keyboard to make the robot move, and as you can see in Arvis, the robot transforms are moving because it is changing its position and the map is starting to form. The darker lines on the map represents the perimeter of the arena, so the walls of the arena. The gray areas represent the areas where there are no obstacles. And with that, our map is complete.
Now we're gonna start our automated module. So we're gonna be trying to run around and pick up trash objects. So first let's go ahead and boot up our base again. So our base was run on from this terminal, so we're gonna go ahead and turn that thing on. Let's see our map, how clean and nice it looks. So we're gonna go ahead and let's get rolling. So let's go ahead and turn on our brush. Our brush is turned on with a GPIO connection to our relay, so our brush is currently on. Then we're going to go ahead and start the module from one of these terminals. So let's go ahead and see. There it is. That's our plans. These are plans. So launching our module, we'll see some changes in Arbis. On Arbis, you can see that it's now estimated based on our parts. So let's move and let's make our robot point this way, straight forward. So I was able to pick up a can. Now let's go ahead and pick up the rest of our stuff. So let's go ahead and try to make it rotate. And it's gonna rotate towards correct orientation, to the orientation as specified. So now let's make it turn this way. Let's get a little closer and it's going to try to turn. Good. Now it's going to move forward. And it's able to pick it up. Oh, okay, that's fine. We can always go ahead and pick that up since it's a bottle and the bottles do not like to roll out. So we can turn around We get a 2 for 1. And try to get a 2 for 1. See? There we go. So now we're gonna be able to go to our next item. So our next item is a little bit more tricky to get to. Right now our brush is doing its best to, there we go, to put the trash inside the bin. Let's go ahead and relocate our robot. So now due to the design constraints, we have to stop using our navigation and have to manually back up the robot. The robot cannot see to the back of itself because of the trash bin. Further implementation would have added infrared sensor or some other sensor on the back to be able, or a camera to be able to notice that there was kind of like a parking camera, that there was a trash bin on the back of it, and to know how much distance it should back around. And now we're going to dispense our trash. Our trash will be dispensed using another command. If I can find a free command line, go ahead and let's go ahead and turn off the brush. Let's go ahead and turn it on again, just a little bit, and dispense our trash. So now our trash will be dispensed by using this script that turns on a GPI on a motor controller with the 2 motors on the back. We'll go ahead and that's it.